I'm the corporate energy engineer for General Mills. We have a 2% energy intensity reduction goal for all of our plants. That means weighted across the volume of product that we make, we expect to reduce energy year after year. And we track that for each plant. In addition, we have a greenhouse gas emissions goal. It's 28% by the year 2025, and 8% of that is going to come from manufacturing. That is our goal. A little bit about myself. I have 20 years of experience in manufacturing, over 20 years experience, and most of that was spent in production. I was a production engineer, process engineer, manufacturing engineer, however you want to call it. I reduced losses in production lines for a variety of different products, companies, General Motors, Ford, Whirlpool. And then I spent a little bit over 3 years reducing energy. There's a long story around me getting from production to energy, but let's just say that I made the request to be an energy engineer without really knowing what that was, and it was a request that was filled relatively quickly. And I had no regrets, actually, but the first time I saw a compressor was actually after an air compressor, and the air compressor room was after they told me I was going to be an energy engineer. My onboarding, it consisted of the utilities supervisor taking me to the engine room. Here's a chiller. He showed me the chiller. Like, okay, what does that do? Had no idea. I think that it's an established rule that when people go into a utility area, they open the door just enough to squeeze through and they close it behind them. You have no idea what's going on in utility areas. That's my defense. But I had a lot of surprises when I went from production support to working with utilities and energy. The first thing that I noticed was that plant leadership, utility support groups, they really don't have a clear line of sight as to what their utilities cost them. Not just the electricity bill, the natural gas bill, but I mean everything that goes into supporting that utility. Most of the time, plant leadership does not know that. Also, I noticed that utility groups don't have the same kind of performance metrics to indicate that they're doing a good job. Typically, if they keep the plant running, they've done a good job. When it comes time for their performance evaluation, it's very different from a production engineer, whether they made product or not. That was a surprise to me. And then another surprise was the amount of money that utility groups spend with autonomy, reacting to a problem. There's a lot of, hey, I'm about to shut the plant down, I need a new compressor, I need a new boiler, I need a new chiller, I need a new cooling tower. Those are very pricey things. And they don't really add value to our consumer. Our consumers don't care whether or not we are making product with a VSD compressor. That's not where we want to spend the money. So that surprised me. If I wanted to buy a new packaging line, a new cartoner, I had to go to what was the equivalent of a congressional hearing. I had to sit in front of directors, and they would interrogate me all day to ask for a little bit of money, but a utility engineer, an energy engineer could ask for great sums of money without a lot of pushback. That was a surprise. And again, plant leadership doesn't really care what goes on in utilities as long as production is not shut down. That was a surprise. Then I had some surprises to my energy role. This is like all kinds of surprises, like my birthday, get a new job. I learned that people in the plant, when they're supporting production, they don't really care about energy. And that's kind of a harsh thing to say, they don't care about energy. It's really that they are focusing on more important priorities. And they're not really interested in the utility bill that we get. I was the energy engineer initially at a plant in Murfreesboro, Tennessee, and nobody in the plant knew that we had $12 million utility spend. That wasn't common knowledge. And then the other thing that I learned in the energy role is that people like the stories, like they like the big savings. That actually is what got my interest. Reading about the economizer, the flash steam recovery projects that saved $500,000. They really like those stories as long as they don't have to be involved in them, right? That was a surprise to me. But people in the plant are using the energy. And that's the problem. So how do you get people to care about something, the energy, or how do you get people to work on something that they really don't care about? And so I came up with a plan that I'm going to implement energy projects, but not working on energy. That is my big strategy. You're intrigued, yes. It's intriguing. Find out what people are interested in and figure out how to make an energy play. That's what I'm going to talk about. Compressed air leaks. I think I've counted the word leaks about 167 times so far this morning. There are 3 things in the world I hate. My top 3 things I hate: turkey bacon, non-fat ice cream, compressed air leaks. You would think that compressed air leaks everybody be rushing out to fix them. That's what I thought. It's another surprise. People be rushing out to fix compressed air leaks. You hear them, they're annoying, but surprisingly, nobody is really that engaged in fixing compressed air leaks. It might be just me. But compressed air leaks, when I was a packaging systems engineer, I actually did fix compressed air leaks on my equipment because it stopped the equipment. The air was there for a reason. It had to have a certain pressure. If you got too many leaks, your critical motions were slowed. We're making thousands of cups, packages a minute. It's very high-speed equipment. You don't get the right compressed air pressure, your machine doesn't operate. It slows down. It jams. It destroys product. Now, operations, they might not care about the air leak, but they do care when their line goes down. And we especially care when we destroy product. That is product that the consumer should be getting. Ingredients are the thing that costs General Mills the most money. You'll be pleased to know that the consumer gets, I'm just going to go ahead and assume that everybody eats General Mills products. If you don't, you're not eating well. The consumer gets the bulk of our costs. So that is the play you make, right? You don't go to operations, you talk about the energy bill, compressed air leaks cost money. You talk about the stops, the production downtime, the product destroy, overuse that the leaks cause. That's the play. We have a lot of dust collectors. We have over 1,300 dust collectors in North America in our General Mills sites. The plants are cereal plants, our flour mills. They usually use about 40% of our compressed air. And it's a lot of variable load too. The problem with dust collectors is that one leak on a diaphragm valve can cost you anywhere between 250 and 300 CFM worth of leaks. You get enough of those, it's an entire compressor. You get enough of those, you're shutting production down. We actually did have a plant where it's a plant that has 300 dust collectors, and they actually were having issues. They actually had twice as much compressor capacity than they need to run. But they got to the point where they had so many leaks on their dust collectors that they started to shut production down. So I just said, you make a production play, you can get people to fix leaks. And they did fix the leaks. They fixed them just enough to not shut production down anymore. It's a lot of compressed air being used there. So we're still having problems prioritizing getting the rest of the leaks fixed. I have twice as much capacity, air compressor capacity, that I need in that plant. But if there are two things at General Mills that's more important than product going out the door. Two things. That is human safety, the safety of our employees, and food safety, the safety for our consumers. So when you get a certain number of leaks on dust collectors, they tend not to remove dust from the air. And now you have a human safety issue, right? So that is the play. You know what's important to your company. The play becomes the human safety issue. And since the EPA is here, shout out to the EPA, it's an environmental issue too. That's the play we make to get that fixed. And in fixing that, you have to fix the leaks so you get your energy savings. Environmental and human safety initiative. That's what that becomes when you work on it. I'm going to talk about steam real quick, even though this is a compressed air conference. Because we have steam leaks just like we have compressed air leaks. Steam is number 4. It didn't make my top 3. It's number 4. But we use a lot of steam. Most of our thermal energy to cook product comes from steam. And we have quite a few steam leaks. Steam, if you look at it from just a natural gas standpoint, is very, very cheap. Natural gas is cheap. People don't take into consideration chemicals, all the water treatment that goes on with boilers, the expensive components that fail. All that really should be built into your cost of steam, but people really don't think about that. So it is almost as hard to get steam leaks fixed as compressed air. But all of our ovens, our dryers, all the stuff that makes cereal, it needs very steady temperature control. And if it doesn't get steady temperature control, we end up having to destroy product. So in order to get temperature control, I have to have no steam leaks. I have to have components that work. Again, that is the play I make to get steam leak repair, is the overuse, is the product loss. It's more costly, more people care about it. That's what they're going to work on. In the meantime, I will make sure that I capture how much I save from steam leaks, and that will definitely go into our narrative when we talk about all the great things we do. But when I have conversations with operations, it's all about, this is the impact these leaks are going to have to your product. They're much more responsive to that. So our initiative there is an overuse initiative, not necessarily an energy initiative. So let's talk about fully loaded costs. I'm going to take a detour real quick. That's a really old compressor. That's what I thought a compressor was. No, I'm just kidding. I'm just kidding. So most of the time when we talk about your dollars per 1,000 cubic feet of compressed air, we're really thinking about the power, how much power goes in, how much flow you get out, what your electricity rate is. That's usually where that's calculated. But what we need to start doing, what will help justify those capital projects that you want to implement, those capital projects like replacing air knives with blowers, installing VSD, sequencing controls, those kinds of things, they don't necessarily meet hurdle when you just look at your electricity. And if it doesn't meet hurdle, it's going to be deprioritized, right? What we've been doing, what General Mills has been doing, is making sure we include a fully loaded cost per compressed air in all of our utilities, actually. Any major rebuild, those capital rebuilds that take place anywhere between 3 to 5 years. This isn't just compressors, this is all of our utilities, daily in-house checks, anything that supports that utility, our service contract, our parts, oil and the power, and then we happen to use water cooling compressors, water-cooled compressors, so that also gets tied into the fully loaded cost per compressed air. And when you start to add in those costs, justifying those projects becomes a lot easier. But remember at the beginning when I talked about how the utility groups oftentimes didn't have like a performance metric that they were accountable to at the end of the year past, hey, I didn't shut the plant down, I did great. Well, you give people, once you have a fully loaded cost per your utility, then you can go back to those utility groups and say, your performance this year is based on a 10% reduction or a 20% reduction of that utility. And you know exactly how that's broken down because you've calculated it. You know how much of that is maintenance, you know how much of that is energy, water cooling, whatever that is. You let them decide how they're going to approach bringing that cost down. Hopefully they'll go after energy, but even if they go after, let's say, maintenance, they're going to just have their air compressors run better. You know, if things run better, they're going to use less energy. You'll get your energy play when people focus on maintenance as well. So now you have performance metric goals for your utility groups instead of an energy goal. So again, however they decide to tackle that, you've empowered them to come up with their own initiatives. And any way they break that down, you're going to get energy savings. Just have to keep up with it, right? Okay, so this is a true story. This is a very rough schematic of a plant that we have in Georgia. We have 8 air compressors in 2 separate locations. 5 of the air compressors, they use heated compression desiccant dryers, and 3 of them use non-cycling refrigerated dryers. They have the ability to tie together. Again, this is actually the plant I was talking about that has twice as much air capacity than they need. And these are some of the oldest compressors I've ever seen. This is probably the first air compressors ever made, pretty sure. And again, this is a system that has over 300 dust collectors, serial plant. And in addition to that, it supports production. And in production, there are also additional dust collectors. It has this plant, when I first started working at this plant, again, we were shutting production down because of leaks. And you would think that if I could convince the plant to make a 50% reduction in their leak rate, and it's not hard. We're not even at the point where we need to take out ultrasonic leak detection equipment yet. We're at the point where you can just walk through the plant and hear the leaks. That's where we're at. So if I can convince them to reduce their leak rate by half, and we could save $350,000, because that includes maintenance. You think they'd be jumping at that? Wouldn't you be jumping at that, right? No. It wasn't. Assuming a 50% in maintenance and service should be enough to justify working on compressed air, don't you think? No. What's gotten their attention is the capital avoidance. That's what gets their attention. They're 30 years old. Those compressors are 30 years old. All 8 of them are ancient. At some point, they're going to have to be replaced. Some point soon. You can replace all 8, or you can replace 4. That's what's getting people's attention. Roughly $250,000 a compressor. I've also got to replace those refrigerated dryers, because they use R22. Those are also extremely old, first dryers ever made. More capital. We could spend that money better somewhere else, period. So, again, I'm from Tennessee. I felt obligated to end with a quote from my favorite country song, which also happens to be the only country song I know. You can't make your heart feel something it won't. You can't make other people's heart feel something it doesn't. You can't make people work on energy if they're not interested in that utility bill. But what you can do is you can find the things that people do care about, the production downtime. Maintenance managers usually care about that maintenance budget. Find the things that they're passionate about and make an energy play. Energy is pretty much tied to everything if you can get creative about it. Do what people care about, find out what motivates them, and then get your energy savings. That's it. Thank you. Thank you for your time. Thank you, Rod, for inviting me. It's been a pleasure being here, and I look forward to this conference. Thanks.